Wind energy, done by Alien Gonzalez.
Wind power or wind energy describes the process by which the wind is used to generate mechanical power or electricity. Wind turbines can convert the kinetic energy in the wind into mechanical power. This mechanical power can be used for specific tasks, which can be converted into electricity by a generator. Fausto Veranto discovered wind energy. He was born in 1551 and died in 1617. However, the very first electricity generated wind turbine was built in 1887 in Cleveland, Ohio by Charles F. Brush. Brush was an inventor and electrician. Historical records say Brush built the impressive 85-foot tall windmill in his very own backyard. In the past, people used wind energy to propel boats along the Nile River as early as 5000 BC. By 200 BC, simple wind-powered water pumps were used in China, and windmills with woven reed blades were grinding grain in Persia and the Middle East. New ways to use wind energy eventually spread around the world. By the 11th century, people in the Middle East were using wind pumps and windmills extensively for food. The Dutch developed large wind pumps to drain lakes and marshes in the Rhine River Delta. American colonists used windmills to grind grain, to pump water, and to cut wood at sawmills. Homesteaders and ranchers installed thousands of wind pumps as they settled the western United States. In the late 1800s and early 1900s, small wind electric generators, which are also known as wind turbines, were also widely used. One of the most popular uses of wind energy is to generate electricity. During this process, a wind turbine harnesses the energy of the wind. As the wind starts to move the blades of a turbine, a generator starts to turn, which then produces electricity. Several electricity providers today use wind plants to supply power to their customers. Stand-alone wind turbines are typically used for water pumping or communications. However, homeowners, farmers, and ranchers in windy areas can also use wind turbines as a way to cut their electric bills.
What is a machinery? A wind turbine consists of 5 major and many auxiliary parts. The major parts are the tower, rotor, nacelle, generator, and foundation or base. Without all of these, a wind turbine cannot function. The tower in most modern turbines is round tubular steel of a diameter of 3 to 4 meters, which is 10 to 13 feet, with a height of 75 to 110 meters, which is 250 to 370 feet, depending on the size of the turbine and its location. The rule of thumb for a turbine tower is that it has the same height as the diameter of the circle of its blades, making when rotating. Normally, the taller a turbine is, it is subject to more of the wind with higher speed. This is because the farther we are from the ground, the faster the wind. The rotor is the rotating part of a turbine. It consists of mostly 3 blades and the central part that the blades are attached to, the hub. A turbine does not necessarily have the 3 blades. It can have 2, 4, or another number of blades, but the 3-blade rotor has the best efficiency and other advantages. The nacelle is housing on top of the tower that accommodates all the components that needs to be on the turbine top. There are quite a number of components for the proper and healthy operation of a complicated electromechanical system that a turbine is. A major turbine part among these components is the generator and the turbine shaft that transfers the harvested power from wind to the generator through a gearbox. The generator is a component that converts the mechanical energy of the rotor harnessed from wind to electrical energy. A generator has the same structure as an electric motor because a generator must be rotated at a speed corresponding to the frequency of the electric network, which is 50 or 60 Hz in most countries. It must be rotated faster than the turbine rotor. Most generators need to be turned at 1500 RPM for 50 Hz and 1800 RPM for 60 Hz. In no way it is feasible for a turbine rotor to move that fast. A gearbox therefore must increase the turbine's rotor, which is the main shaft, rotational speed to a speed that can be used by the generator. The foundation is under the ground for the onshore turbines. It cannot be seen because it is covered by soil. It is a large and heavy structured block of concrete that must hold the whole turbine and the forces that affect it. For offshore turbines, the base is under the water and cannot be seen. In offshore turbines that are well into the sea, the base is floating, but it is of sufficient mass to support the turbine's weight and all the forces exerted on it and to hold it upright.
Wind turbines work on a simple principle. Instead of using electricity to make wind like a fan, wind turbine uses wind to make electricity. Wind turns the propeller-like blades of a turbine around a rotor, which spins a generator, which creates electricity. Wind is a form of solar energy caused by a combination of three concurrent events: the sun, unevenly heating the atmosphere, irregularities of the Earth's surface, and the rotation of the Earth. A wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades, which work like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both lift and drag. The force of the lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to the generator, either directly or through a shaft and a series of gears that speed up the rotation and allow for a physically smaller generator. This translation of aerodynamic force to rotation of a generator creates electricity. Many wind technicians learn about their trade by attending technical schools or community colleges. They then typically complete certificates in wind energy technology, or some would move on to get their associate's degree. Many of these technical schools have on-site wind turbines where the students can get hands-on experience and practice for their studies. Belize currently has about 3,500 square miles of area offshore that produces wind resources, which are rated between moderate and excellent. This wind plant exceeds to roughly 70 miles from the coastline. Our country, Belize, is filled with many places where wind turbines would be very effective. I have carefully analyzed the map of the country and selected 2 places where I believe would be very beneficial to place a wind farm. A wind farm is a collection of many wind turbines grouped in the same location. Both these proposed wind farms are situated onshore. The first location I thought about was the Pine Ridge area in the Kaya district. The Pine Ridge area is covered with many mountains and extensive highlands where the winds would hit these wind turbines perfectly. This wind farm would also be very accessible given that there is a road that cuts perfectly through the Pine Ridge area. The wind energy would then be transported to the nearby villages among Pine Ridge and to the further villages like Santa Elena and San Ignacio. The second location would be the Sibun Forest Reserve. This area consists of vast lands where a wind farm would be nicely situated. These wind turbines would need to be placed in a specific area where they would all work together and cause no damage to any civilizations nearby.
In the picture to the top, we can see the Pine Ridge area, and in the picture to the bottom, we can see the Sibun Forest Reserve.
Environmentalists would agree with my proposal since wind energy is a renewable resource and causes no harm to the wildlife or forests if kept under supervision. Oppositions wouldn't stand a chance in debating whether or not these wind farms should be set in place because there are many reasons why it will be beneficial to our country. For example, many more jobs would be offered to help with the maintenance of these wind turbines. These big wind turbines are no doubt going to be expensive. The prices of these different wind turbines are determined by the amount of electricity producing capacity, which is normally measured in megawatts. Many onshore wind turbines have a capacity of 2 to 3 megawatts and can typically cost around $1.3 million per megawatt. Let's say 3 wind turbines of 2 megawatts capacity are placed at both the locations I proposed. The cost price will be around $15.6 million. These prices may look really high, however, wind turbines have a tendency to pay back for themselves over time. The more electricity the wind turbines produces, the more money is generated. With all this, the power can be sold back to the electrical grid of utility companies, and the money spent can be generated back just in a couple of years. In the longer run, the investment will be beneficial to the country, while the electricity of the country lies among renewable resources.
These prices are in US dollars.
A fun fact is that China is a leading country in wind energy with a whopping 288 gigawatts of power at the end of 2020. Doing the maths, that gives 288 billion watts of power. More and more other countries are finally switching over to and investing in wind energy because it is a clean and renewable way to generate electricity. For example, the president of Portugal managed to establish wind parks in the country since they had all efforts in the production of renewable energy. Furthermore, wind turbines generate 1/4 of all the electricity that the population uses in that country.
Even though wind energy has been increasing over the years, there can still be some positive and negative effects of wind power. For example, the greatest advantage of wind energy is that it is clean and renewable. The wind powers these wind turbines, and the wind will never run out, since it naturally occurs in our atmosphere. The operating cost of a wind turbine is moderately low, considering that the fuel, in this case the wind, that requires the wind turbine to rotate is free. The turbines do not require much maintenance after they are installed. The land used for these turbines can also be used for other purposes, such as farming, considering that the actual turbines and equipment does not take up a lot of real estate. Some disadvantages of wind energy is that the wind is inconsistent at times. Many times, the wind will decide to not flow enough on a specific day, where high electricity is demanded. Wind turbines also cause noise pollution because of the operation of the rotation of those giant blades. Wind turbines can also have an impact on the environment. Since the turbine blades are large and rotate at high speeds, animals that fly into them can either be harmed or killed.
It is clearly evident that wind energy has evolved over the years. The Wind Energy Technologies Office works with partners of different industries to increase the performance and reliability of next generation wind technologies while lowering the cost of wind energy. Power plant productivity increased from 22% for wind turbines installed in 1998 to about 35% now, up from 30% in 2000. Wind energy costs have been reduced from 55 cents per kilowatt hour from 1980 to less than 3 cents per kilowatt hour in the US today. New developments / extensions in modern day turbines are increasingly cost effective, more reliable, and have scaled up in size to multi-megawatt power ratings. With the help of the Wind Energy Technologies Office, research has helped facilitate the transition to the development of longer and lighter rotor blades, taller towers, more reliable turbine powerhouses, and performance optimizing control systems. The physics of wind energy can be narrowed down to 3 features: the size of the windmill, the number of blades, and the shape of the blades. Let's start off with the size. The bigger the area, the more wind you can use, and therefore the more wind energy you can capture. Also, the higher above the ground you go, the less the wind itself is disturbed by other objects, and therefore again, the more wind energy you can capture. Wind turbines need to capture the wind energy while also letting the wind pass. Let's say 100% of the kinetic energy from the wind was taken. Then it would stop the incoming wind and wouldn't have anywhere to go. So therefore, some wind has to be let through, and by calculations of Betz law, which states the equation of wind power, P wind equal half rho AV cube, where rho is the density of the air, A is the swept area of the turbine, and V is the wind speed. The average wind turbine can only extract 59% of the wind's kinetic energy. With that said, for fast-moving wind turbines like the modern ones, they need correspondingly fewer and thinner blades so that the wind is not slowing too much, while older and slower windmills can have more and wider blades. But why are modern wind turbines designed to spin more quickly than old wind turbines? The answer can be found in Newton's third law. Just as the wind pushes the blades sideways to turn them, so the blades push back on the wind, giving the air a reverse finish. So therefore, rotational kinetic energy is obtained, which is K E rotational equal half I double squared. However, the windmill doesn't capture this energy. Therefore, the most efficient wind turbine will give the wind with the least twist possible. So the faster the windmill moves, the less rotational energy is given off. In essence, the ideal wind turbine should be big to capture a lot of wind, tall to capture strong wind, fast moving to be most efficient, and narrow bladed with fewer blades to not slow down the wind too much.
This is the in-depth bibliography of the presentation. Thank you for watching.
Don't forget to like and subscribe.